Hello everyone. So today we will discuss about light emitting diode. Initially we should learn about some points about light emitting diode. First point, LED is basically just a specialized type of diode as they have a very similar electrical characteristics to a PN junction diode. It means light emitting diode passes current in forward bias case and blocks current in the reverse bias case. Second point, the device is capable of emitting a fairly narrow bandwidth of visible or invisible light when its internal diode junction attains a forward electrical current or voltage. The visible light that an LED emits are usually orange, red, yellow, or green. The invisible light includes the infrared light. Third point, the efficiency is almost 50 times greater than a simple tungsten lamp. The response time of the LED is also known to be very fast in the range of 0.1 microsecond when compared with 100 millisecond for a tungsten lamp. So next is working of light emitting diode. So this is the diagram of light emitting diode is very much similar to diagram of PN junction diode. But there is a difference is the material used in this diode. In case of PN junction diode we use silicon or germanium atom, but in case of light emitting diode we use different types of material because different types of materials emits different color of light. So the process in the light emitting diode is very much similar to PN junction diode. So this is the positive terminal of the battery and this is the negative terminal of the battery. Positive terminal of the battery repels holes toward the junction. Similarly, negative terminal of the battery repels electrons toward the junction. And in case of forward bias case, depletion layer is very thin, so there is a great possibility of recombination of electron and hole pair near the junction. As we know that electron in the first orbit has lowest energy and electron in the outermost orbit has maximum energy. So free electrons in the n type that enters in the conduction band because energy level of conduction band is higher than the valence band, and holes that remains in the valence band. The energy difference between valence band and conduction band is equivalent to band gap energy. When the electron in conduction band recombine with hole that in valence band, in this recombination process energy emitted in the form of photon and this energy is equivalent to band gap energy. नेक्स्ट इज यहाँ क्वेश्चन अराइज होता है जब लाइट एमिटिंग डायोड और पीएन जंक्शन डायोड दोनों का प्रोसेस सेम है तो पीएन जंक्शन डायोड में लाइट एमिट क्यों नहीं हो रही है. इसका आंसर इन दोनों पॉइंट्स में है. तो फर्स्ट पॉइंट, द इलेक्ट्रॉन डिसिपेट एनर्जी इन द फॉर्म ऑफ हीट फॉर सिलिकॉन एंड जर्मेनियम डायोड या फिर पीएन जंक्शन डायोड, बट इन गैलियम arsenide phosphorus and gallium phosphorus semiconductor the electron dissipate energy by emitting electron in case of light emitting diode. Second point, if the semiconductor is translucent the junction becomes the source of light as it is emitted, thus becoming a light emitting diode. But when the junction is reverse biased no light will be produced by the light emitting diode, and on the contrary the device may also get damaged. Next is advantages of light emitting diode. First point, very low voltage and current are enough to drive the light emitting diode. That is a big advantage for light emitting diode. Second point, voltage range is 1 to 2 volt. Third point, current is approximately equal to 5 to 20 milliampere. Next point, total power output will be less than 150 milliwatt. Next, the response time is very less, only about 10 nanosecond. Next, the device does not need any heating and warm up time. Next, miniature in size and hence lightweight. Next, an LED has a lifespan of more than 20 years and it is much higher than the normal bulbs. Next is the disadvantages of light emitting diode. First point, a slight excess in voltage or current can damage the device. Second, the device is known to have a much wider bandwidth compared to the laser. Third point, The temperature depends on the radiant output power and wavelength. Fourth point, it is expensive. LEDs are more expensive as comparable to normal bulbs. Next is the applications of light emitting diode. First, LED is used as a bulb in the homes and industries. Second, the light emitting diode are used in the motorcycles and cars. Third, these are used in the mobile phones to display the message. Fourth, at the traffic light signals LEDs are used, and many more.